I'm
Okay, great. Well, thank you, Sissy and Rennie, for inviting me. It's a real pleasure to be letting me share some of our research ideas with you. First of all, I'm sorry I couldn't be there in person. I really wanted to come, and it wasn't a travel thing. I'm in this faculty fellowship program, and we've had 4 days of a 4-day retreat, so I couldn't get away from that. I'll try to keep this relatively short so we can have time for some questions and discussion. Just to give you some context, our institute is finishing up our second year. The first year was started entirely through COVID. So it was basically a lot of getting set up in survival mode and so on. But now we've been able to actually get some research going and some results going to the point where you can start kind of piecing together a story of how we're thinking of reimagining AI in education. And that's just one way in which we're doing it. There's many different perspectives on how we might do that. So just a little bit about the NSF National Institute programs. So this was actually part of the National AI Research and Development Plan. And they're kind of focused on these long-term high reward AI research with many themes. So they are planning on funding like 25 over 3 years. They funded about 18 total. And these are large investments of the NSF. So this is kind of just a mapping of the different states that have been funded. And we were one of, there have been 3 AI institutes on the intersection between AI and education. And we were the first, and there were 2 more funded last year. And I think they're planning on funding some more. So we're a big and interdisciplinary team. So our institute unites researchers from 14 different areas, along with students, postdocs, and partners. So we've got 9 universities across all time zones in the US, school districts, development partners, industry, and so on. So it's a very nice, broad, diverse team. Time permitting, I've kind of carved out some slides at the end to just talk a little bit about how some of the things we found helpful in trying to integrate a diverse team spread across the country like this, just to start the conversation. Here's our team of faculty and research staff. This is around May of this year. It's kind of grown. Here's a selected list of grad students, postdocs. So it's a really robust and wonderful team. And it's my privilege to share their hard work with you today. So one of the first things that came up when thinking about an institute, and just to give you some context here, I've been working in the space roughly of AI and learning. What I'm really most interested in personally is trying to understand human cognition and human emotion. But that doesn't arise out of a vacuum. It arises in a context. And so we've been looking at this largely from the context of acquiring high quality cognitive and high level cognitive skills. And learning is one example of some of those skills. So our interest in learning really comes from a foundational interest in studying human cognition and human minds. With that said, we also believe in studying these items from the perspective of the computing sciences, because of a theoretical philosophical approach that says to really understand something, it really helps to model it. And computer models can tell you how things are going and when things are going wrong. And lastly, the third point I want to say is that when you have a model, it's a physical thing, so you can actually use it to do things and make change. So also looking at things from an engineering approach, how can we take our science and our models to actually have some impacts? And this institute is a good example of putting those together. So when we were thinking about an institute, what are some opportunities for innovation for AI in ed? Artificial intelligence in education is an old field. It's going back for about 50 years or even more, right? So it's been pretty rigorous. And they've had a lot of successes. And in part of this community, but there's been one kind of persistent aspect in which much of the work, not all, but most of the work has largely focused on kind of individual students interacting with the computer. So you can think about that model of intelligent tutoring systems, the computer adaptive learning, or educational games. It's largely one-on-one. There's some work in collaboration, but it's mainly one-on-one. So one idea of innovation we thought about was really this enhancing this bandwidth of communication from unimodal. It's mostly through chatting or through keystroke logs or when you're clicking on an interface, through this multimodal, multi-party, naturalistic social interaction. So basically saying, let's try to sense human interaction as it's occurring, and let's focus on humans interacting with individual humans. That's the exciting stuff. Second, this idea of developing the whole students. If you think about the challenges facing a society today, from global warming to fires, that's very near and dear to us, being here in Colorado, to the pandemic, you really need the kind of skills and teams you need to tackle these challenges. It really lies in getting people together of diverse areas to come together with core skills. So the days in which you are an expert in math and a math class can only teach you math is kind of insufficient to meet the demands of today. So we're really thinking about curriculum, about how do we teach kids 21st century skills along with their disciplinary content. So while you're trying to learn math or physics or anything, can you also learn how to be a good collaborator? Can you also learn persistence? Learning is hard. How do you struggle through? How do you manage your frustration? And how do you develop teamwork skills? So the idea is building the whole student in an integrated way. And lastly, when we thought about AI and AI and ad, ethics was something in the back burner. It was never front and center. The way the thinking almost went was, yes, we'll look into privacy and security, and I'm speaking in overgeneralizations here, but very rarely did we put ethics front and center. But now with AI, we've seen both the great things that can be done with technology, but also of significant harms that can be done with technology. So I don't think we have this luxury to sit back and say, I'm just going to focus on the science and engineering, and I'm not going to worry about whether it's misused or how it's used. I think we have a responsibility. And so a third opportunity here is to kind of rethink, what does it look like to have ethical and equitable AI? And one way our institute is targeting this is by asking the question, what is it that AI should do, and not only looking at what it can do? And another way of thinking about this is putting humans and human needs and human flourishing in the center of the technological space, instead of the technology in the center with humans hovering around it. So I want to connect these three ideas with how we've been thinking about our institute thus far. So we started with a central question, and that question is how to promote deep conceptual learning through rich socio-collaborative learning experiences for all students. So a couple of points to unpack here. We're kind of interested in learning experiences that are deep, and deep means they're persistent. They stay for a while. They're not superficial, like you're cramming it for an exam kind of thing. Secondly, deep learning is integrated and it involves connections among concepts. It involves conceptual change where you're acquiring some new information by reshifting your existing mental models. And lastly, deep learning is learning that you can transfer. You can transfer what you've learned to new tasks. It's very, very difficult to actually promote deep, meaningful learning. However, one way to do this is through engineering rich socio-collaborative learning experiences. And the basic idea is people learn by telling and doing, and learning is essentially a social activity. So can we promote deep learning through supporting these activities? Now, these are not new ideas in the learning sciences. This has been known for like 50 plus years. The challenge is it's very hard to implement this as a teacher. So imagine a teacher in a class with about 25 students engaging in collaborative learning. So she may split them up into groups of 3, and now you have 8 conversations occurring simultaneously. How is one human being who's not omnipresent being able to keep up with all of that? For one thing, 2 things happen. One, many times students are struggling, but they can't get attention to the teacher and the help that they need. And so they might get disengaged, go off task. But the other side, students are having wonderful, rich conversations. Ideas are coming through, but this is totally lost on the radar of the teacher. The teachers are not there to listen to it. But if the teachers have a sense of these conversations, they can be really invaluable in seeding authentic discussions because you're giving students the voice. So these are some of the challenges that you face in trying to engage in social collaborative learning. I taught an AI course. I teach a huge AI course with like 106 students, and from my own personal experience, I try to have one collaborative learning activity in every class, and that's partly so students are encouraged to show up. But it's amazing. So if I might be lecturing for the first 20 minutes, it's pin drop silence, people are dozing off, and suddenly the entire classroom comes alive when I do this kind of collaborative learning. But the challenge is I'm running around trying to support like 50 groups, and it's exhausting. And I do this twice a week. And I'll think about a teacher that's doing this 5 to 7 times a day, every single day, right? It's a testimony of their dedication. So in thinking through that space, we thought about AI as this view of AI as the social collaborative partner that helps students and teachers work and learn more effectively, engagingly, and equitably. So what that might mean, and we're still figuring this out as we go, this was just our original conceptualization, but imagine an AI that can take on many forms, like a disembodied voice or some computer simulation, or even an embodied little agent. But it's listening in on these conversations, and it's doing a variety of things by taking on many roles. So for example, it can participate in the conversations, or maybe it's just taking notes of the conversations, or it's providing some help when they're struggling, and so on and so forth. But in addition to listening and working with the students, the AI is always feeding information to the teacher, because the teacher is always in charge of the classroom. So the idea is for the AI, the student groups, and the teacher to kind of form this synergistic partnership that helps make these classrooms, helps collaboration in the classrooms more effective and engaging. One other thing is AI is not constrained in time and space. So it might be able to figure out what are optimal student group assignments, both in real time as well as over time. So there's a lot of potential there from opening in these group discussions through AI technologies. But as we'll see, there's also a lot of concerns and cautions that we need to be mindful of. So I'll come to that in a second. But then to the second opportunity, what we've been thinking about is actually using AI education itself. So our institute is focused on promoting AI literacy. There's been a lot of efforts in the last several years to make AI literacy part and parcel of middle and high school K-12 curriculum. It's very much in its infancy. So we thought this is an opportunity to integrate our work with the goal of developing AI literacy in the nation. So the way we do this is you can't just show up to a class and say, I'm going to teach AI. They won't let you in. So what you have to do, a strategy is to integrate AI education in existing STEM courses. So for example, if you're learning about genetics, this could be a good way to think about genetic algorithms, which is an AI search technique. So that's just an example. So basically, we're thinking about promoting a range of learning games at a very high level. This is the domain knowledge, what students learn. Also, these 21st century skills. We're focusing a lot on collaborative problem solving. How groups of people come together to solve complex creative problems that there is no obvious solution to. And this is kind of these are kind of the skills that are very much valued in the workforce today. In addition, thinking critically about problems and challenges. At the same time, we want students to engage in rich discourse. There's a lot of work and theories on the importance of having rich academic discourse on student achievement, and also on inquiry, where there's curiosity and students come in and discover. There's a sense of discovery and interrogation of a complex system, as opposed to all the answers being presented to you. And then there's hopefully through rich, good curriculum, we are hoping to promote interest, curiosity, self-efficacy, and be very mindful to students that AI is powerful, and AI can be a source for good and evil, actually, and helping them appreciate the nature, behavior, power, and consequences of AI systems. And our institute also plans on working through pathways, very much like yours, the current institute you guys are launching, where students we want to work with students from middle school to high school to help them contribute to this AI-based workforce. And then the third opportunity is about responsible ethical AI design. And what we've done is we've adapted this framework, which we call the framework of responsible innovation. And the basic idea here is it's a set of principles that helps you think through every design decision from the ground up. And the idea is of taking care of the future through collective stewardship of science and innovation in the present. And it has different angles, so you're at different stages of design, but this framework is a way for us to think through what is it that we're doing with intentionality. And I'll unpack some of these ideas as we get along today. So we've organized our research into 3 distinct research strands. This is very brief. One is focusing on the foundational AI that's required, and this involves speech and language, computer vision, and some gesture recognition, and also dialogue management. That's very much foundational AI. And on the other side, strand 3, this is focusing on how do we implement this responsible innovation framework? What are the curriculum redesigns? Basically looking at how do we develop AI literacy curriculum that promotes learning, but is embedded and can work in school systems, while at the same time incorporating some aspects of AI technology. And integrating the two is the strand 2, which is focusing on collaboration, computer-supported collaborative learning, and team science. So you can think about this as mainly human-computer interaction in team science people. And then there's so much of integration and coordination that we actually have established a community hub, which is a group of individuals who kind of help everybody to keep everybody talking and support this idea of multidisciplinary collaboration and multi-organizational integration. So how are we going to get to our student learning outcomes? And I just want to have just one slide to kind of connect the pieces up. And this idea is, what is our theory of change? So first of all, everything starts with good curriculum. And what a curriculum is a set of activities, lessons, thematic items that students engage in systematically, and it can take from a week to about a month. So we work with, and part of our institute has some nationally renowned leaders in developing curriculum for science. So they develop amazing curriculum by working with students that is highly cognitively demanding, so it's challenging, but it promotes inquiry, collaboration, a lot of talk, and students themselves pick the focal topic. So we do a lot of work with students. What are you fascinated about? And that forms the bedrock of the curriculum. So that's a way you can already get some great learning outcomes. But to elevate it further, it's this idea of social collaborative learning, and I talked to you about some of the prescribed benefits. So there's a mediated path through social collaborative learning. And then the way the AI partner fits in is different designs of this AI partner can facilitate different forms of social collaborative learning. We don't have all the answers. We don't really know what is the right blend, how students should be actually collaborating, and how do we promote collaborative learning opportunities. And the idea is to test this out to different designs of the AI partner. So kind of this is like a broad roadmap of how these pieces connect together. So let me now just jump into a very selective overview of our research. So let's start by thinking about our process. So starting with the responsible innovation, the idea was when you're designing with youth or for youth, and it's not just the students, it's the teachers, it's the school system, it's their parents, it's community leaders, let's figure out let's talk to them, let's get them in the design from the ground up. So we start with these Learning Futures workshops, which is really getting the youth to imagine what is the future that they want for themselves, not us imposing one on them. Then there's a lot of planning and design that occurs throughout. Then the research occurs at these 3 strands and at the intersection. And I can say a lot. You can actually do a whole talk just on what's happening at these different intersections. But just to say for now, it's a bunch of research occurring. And then we do stuff in the classrooms and also study technology. So I'm going to mainly focus on these 3 sides right there. And throughout, we're trying to do analysis, evaluation, synthesis, and knowledge transfer. So going to these Learning Futures workshops. So one thought was, what is it that youth think about collaboration, and how do they want technology to support them in collaboration? So we engaged 30 high school youth over 10 days. These youth are from California and Colorado, to really deliberate what is collaboration, what is the role of AI. And we learned a lot that formed a major reconceptualization of the possible roles of an AI partner based on the student input. So just to give you some highlights, they expressed their desire to have affirming interactions with an AI partner, in that they wanted their contributions heard, attributed, and to have meaning. They wanted a voice in the classroom with the partner, with their peers, with their teacher, and they wanted their voice to be heard and respected. They didn't want the partner to report any poor behavior to their teacher. This is very critical. We're listening in on conversations. We do not want to be snitching on students to the teacher. And part of their solution was they wanted agency. They wanted the ability to turn off the AI at their will. At the same time, I should also point out, they were totally fine with the AI partner reporting poor behavior on their classmates to the teachers, just not on themselves. They felt, though, that they'd be willing to give up some of their data in exchange for features that they value. So these youth wanted to be respected, but they were also willing to negotiate. And this is one design that came up with the youth. We actually took some of these youth to a cooperative living space in Berkeley, and they saw how do 20 people collaborate to live successfully. And one of the things that comes up is they establish norms. And through that, one of the students drew this light log, and it's a very beautiful concept, but the idea is students and teachers collectively negotiate what are the norms for classroom collaboration that they value, such as no using curse words, no using slurs, and some positive things. And then the idea is, as the AI is listening and sensing in these conversations, these norms light up based on what it senses. And that's just one way to communicate their value system and keep everybody kind of on track. So that's kind of one of the designs we're exploring. So we had a lot of ideas from this, but we then needed to turn this into designs. So what we did is, and these are a bunch of people from our institute, we got everybody together last December, and this was pretty scary because it was, right around the Delta variant. But we had 15 students and postdocs. They came together for 3 intensive days that were facilitated to try to come up with designs and metaphors for the AI partner based on a range of inputs. And I wanted to share with you a little video to illustrate some of the work that occurred at this designs. And can you just give me a thumbs up, if the audio is playing okay?
So one important aspect of ISAT is to consider the role that AI play in classrooms. And a way that ISAT has done this is to institute a design sprint.
I was one of the facilitators for the design sprint. The aim of the design sprint was to develop...
Sorry, is the audio playing?
The audio is coming fine, thank you.
Great, thank you.
A more refined set of metaphors or ideas about how AI can be used in classrooms, keeping in mind how it will impact teachers and how it will impact students. So this allowed for a really interdisciplinary group of people to come together and quickly, within 3 days, come up with some designs.
The design sprint was a resounding success in getting folks from all of these different universities and backgrounds to come together and have a space, safe and creative space to design together. And they had 3 really impressive designs that actually target the entire life cycle of ISAT, ranging from interacting with students to teachers to organizing classrooms.
Gradually now we build up on that to basically execute this to a code where we'll see how we come up with this single partner and see how it functions.
Oops.
Potential AI. I think with a potential AI can do is they can see where the students are and kind of help them and guide them.
That was one of our teachers who was also part of the design work. So through that, you've got 3 designs we're playing with. One is this idea of a community builder. And this is really how an AI can support students in developing trusting, collaborative relationships with each other. And one idea is to, we don't want to impose, this is the type of speech youth should have in a classroom. We're working with a very diverse set of youth, and we want to support non-normative forms of collaboration in creating these equitable collaborative spaces. The second is this idea of something that augments what's happening in classrooms by basically helping relay information between teachers and students, but there's a lot of information. How do you find the juicy nuggets, the important information at the right time, and that can be negotiated and transmitted? And the third one is a little more traditional. This is actually supporting task progress and actually helping them solve their current challenges. So the main point, though, is when we started this institute, we thought about the partner as acting in this top-down manner, intervening with improving capabilities. And we had these metaphors of a sheepdog that's listening to the conversation and, you know, keeping people in place and so on and so forth. But the youth were not interested in that at all. And in fact, they wanted a different viewpoint. And through engaging in these learning futures workshops, we're hopefully designing something that kind of meets them where they are. So let me just talk now to something about what's going on, what we've been doing in the classroom. So a lot of the work in AI requires data and also the right kind of data. So we've made a concentrated effort to develop curriculum that engage youth and collect data that can be used to understand collaboration and also develop AI approaches. So we're working with this absolutely fascinating, I really love this unit called sensor immersion. And what you do is kids really learn about sensors that computers and sensors can sense the world around them and what can be done with this information. This is connected to one of the AI for Core 12 core concepts of sensors can, you know, sense the world and how you can learn from the data. So the way this works, and this is very typically how our curriculum work. So first of all, teachers engage in a professional learning workshops over the summer where they learn the whole curriculum. This just occurred over the last 2 weeks. But then they go and make this sensor display. It's physical sensors that are like sensing the environment, and they light up based on different things being sensed. And the kids don't really have an idea of what's happening, but they actually go in and they have what we call noticings and wonderings. And they think about, why is this moving up? What's happening here? So they're kind of getting into the spirit of inquiry. And then we actually have them work with the physical sensors. And there's a sound sensor, there's an environment, there's a moisture sensor, and there's another like general environmental sensor. And so what happens is the students both physically connect up these sensors and take readings around the environment. At the same time, they also learn to code. They work in pairs and they program the sensors to do all kinds of things. Very simple programs, it's just block coding. So the way we have this work is, remember, we also want to support collaboration. So the students individually form teams of 3, and they become experts in individual sensors. So my team could be the expert in the sound sensor, and your team could be the expert in the moisture sensor. So we then go through several tutorials and we play around with the sensors and we learn all kinds of things about them. And then we come together in a mixed team, what we call a jigsaw, where we discuss our different sensors. And then we work on a solution. We pool our knowledge to work on a solution that's important to us to have a sense of presence. So, you know, they're aware that it's there. And it's also a good mic. So we went through and got a bunch of data. We helped teachers, we supported teachers in implementing this curriculum with about 1,000 students from 2 large school districts. And we had a lot of volunteers and staff and collecting this data all through Delta and Omicron, where, you know, these kids are not vaccinated, they barely wear masks. And so it was really amazing full of effort by our team to do this. Well, we collected about 450 hours of audiovisual data from 500 consenting students and parents. We looked at different types of data. So sometimes we just have audio. We follow the teacher around a lot because there's a lot of information we want to learn from the teacher. How is the teacher supporting the students, and can we emulate that in an AI partner? Mostly we're looking at supporting collaborative learning, so supporting this group. And then sometimes to get context, we just look at this wide view. I'm going to just show you some sense of the data. Now, I want you to think about this from the perspective of a computer who's got to sit down and listen to this and try to make sense of what's actually occurring based on what you can see. So let me just figure out what's actually happening. There involves looking at gesture, looking at the context of what they're doing, looking at speech, and looking at gaze and trying to pull it all together. So it's pretty challenging. And so we've been analyzing and annotating this data at multiple dimensions. So the first 3 are really focusing on very kind of low-level stuff like speech, who's speaking, what are they saying, and then some analysis of content and discourse, turn taking, and so on. And then this idea of situated grounding, grounding language in gesture and reference in the world. Then there's a lot of work focused on talk. So different ways of categorizing talk, and these all come from pretty well-defined theoretical frameworks of how you analyze classroom conversations. And then lastly, we're also doing a lot of work on annotating scaffolds. How do the students support each other, and how does the teacher support them? So this is a massive undertaking of these many dimensions of annotations, but this is kind of how we need to make sense of this complex picture and provide some guidance to the AI algorithms, because we, because the way we're working in this space, we still follow this annotation paradigm for machine learning, which is even critical for deep learning methods, where you basically do a lot of annotation, you give the model some examples, you'll see where it's making errors, and you go through this cycle again. So just to give you one example, here's a collaborative problem-solving framework. So this is one of these boxes, number 6, that our team developed a few years ago, and it basically is, how do you analyze what is good collaboration? And through a lot of work and focusing on actually college kids initially, while they played these physics games or coded, we developed this framework that has 3 what we call facets. One is constructing shared knowledge, how you share knowledge and construct solutions. The other is negotiating and coordinating. How do you negotiate and execute your solution? And the third is keeping the team dynamics going, And importantly, each of these facets has verbal indicators and non-verbal indicators. So what you're coding and what you're analyzing is exact examples of behavior. So it's a very, very grounded approach. And it's not like we're looking at collaboration and saying it's good or bad, So for example, in the physics case, they may say, we got like 2 minutes left, so we might be able to get all these levels. They have a game in multiple levels. That's called talking about the challenge situation, because they're looking at their givens. In Minecraft, the challenge says, yeah, somehow we need to get to the water. So here they're talking about the challenge. Notice how the language can be very, very different. And so we want to think about, how do we design algorithms to detect these collaborative problem-solving facets that is not tied to the language of every domain, right? So we want some things that generalize. So that's actually a pretty challenging problem. So let me just tell you now some of the technologies we've developed, and I'll wrap up soon. So one thing we've decided to do initially, and I want to say initially, is focusing on one of these ideas that came through the design sprint and the Learning Futures workshops, is supporting the exchange of information as an initial step. It's really, really hard to pull off real-time AI in the context of a classroom, because there's many, many technical challenges. I won't even bore you with the details, but dealing with sending sound securely to the cloud and so on and so forth. So we're starting with actually not supporting real-time, but near real-time. So what basically we're thinking is students can have a display. These are all speech-based. Teachers can have a display, and then there's this community display that has information that's kind of shared. So one of the challenges we gave ourselves was, okay, can we build an end-to-end system for analyzing classroom audio and displaying the results about student collaboration? So we worked on this earlier this year, and we just took, because data was still rolling in, we just took whatever algorithms we had and tried to see if we could put them together in a meaningful way. So the pipeline is still pretty involved. It's starting with the low-level acoustics, doing speech recognition, speech diarization, who's speaking to whom, what are they saying, what are the conversational dynamics, and collaboration. What are some collaborative problems? And there's a lot of challenges here because it's multi-party, multimodal, multi-curricular, and it needs to support eventually real-time interaction. And so there's failures of sensing at like all levels. It's a very noisy environment. Speech recognition is awful in this environment. And so errors can accumulate at different points. And the question is, how do we make sense of, and we obviously walked into this knowing the challenges because we've been working in classroom speech for many years, but we still think we can actually make some impacts here. Here's an example of, in the interest of time, I'm just gonna jump ahead a little bit, but there's a lot we've done in terms of speech recognition, modeling collaborative problem solving, some transformer models that are tuned to be generalizable, and also analyzing different types of speech, whether it's on topic and on task. Here are some of the foundational AI. It's just a sampling of some of the foundational AI directions we're looking at. One is this idea that in classroom speech, there's a lot of multi-party speech and it's multi-overlapping, which makes traditional speech diarization really challenging. So my colleague, Jake Weidel and his students developed this idea of compositional embeddings, where you can embed different pairs of speakers. We've also worked on being able to get at gestures, eye gaze from video. And lastly, this idea of grounding language, grounding gesture and language, they've come up with a new way to represent language. So AMR is the kind of way to represent linguistic content, both symbolically as well as in neural networks. And Jammer is a way to incorporate gesture in that. So this is just some ongoing work. So let me now just show you a very brief demo of what we're able to sense from the classroom. And this is intended to just be a display for researchers. There's information in there that we obviously wouldn't want to share with teachers. For example, if a group is going off topic, the students never want that to be shared with the teachers, and we totally understand that. And there's actually a lot of, that's a whole different story, but there's a lot of benefits to going on off-topic conversation. It helps build rapport and so on. So this is just a researcher display, more of a technical thing.
At the NSF AI Institute for Student AI Teaming, we have developed a speech-based AI display for small group collaboration in classrooms. We are an interdisciplinary community dedicated to transforming classrooms into more effective, engaging, and equitable learning environments through developing and refining AI technologies. Here we highlight what we can currently sense in the classroom in the form of a researcher display. We currently display data on student groups at multiple levels, including acoustics, conversation, content, and collaboration. The specific metrics include the signal-to-noise ratio, the number of words spoken, and the words themselves via automatic speech recognition, degree of topic and task-related talk, and collaborative problem-solving metrics, including building knowledge, negotiating, coordinating, and team function. We can also explore the raw JSON output that is generated by the AI pipeline, which includes each utterance and diarization of who said it. We will now show the display running with 7 groups in the classroom.
Why is nothing did we do something that right? Maybe, I think the thing we probably did was we didn't plug something in the right place on the code.
I finally figured it out because I had to use hint. And then we can you stream into this?
Finally, we consider student privacy and agency critically in our designs. For example, students can turn off the sensors when they want some privacy. Overall, this technology is a key step toward.
So now we've been working on instrumenting this, and we're going to be doing some trials in the classroom in the next, next month. So let me just end very quickly by just talking briefly about, given this institute and some of the things we've done that help us build these multidisciplinary and multi-organizational synergies, getting people together essentially. So as I said, we're kind of across the country, and that has a lot of strengths, but also poses a lot of challenges. And we have a lot of different areas. So you're kind of people from the different strands. You have folks who are working on computer vision. At the same time, people working on, HCI and neurophysiological computing, and people working on classrooms and how do you design pedagogies, right? So getting everybody to talk together has been both rewarding and also a challenge. So some of the things we've done that have worked a lot is I want to give you some concrete ideas. One thing here is this idea of conjecture mapping. So what you do is you bring the different stakeholders and they try to map out what is happening at every level with a given feature. So here's the conjecture map for task and topic related talk. It's based on a theory from the learning sciences on some of the benefits of actually having non-task related talk. And so you imagine in the back end, you have decisions like, what is my classifier? What is it doing? How accurate is it? What is it sensing? And then you can think about the front end decisions. Maybe we can let the youth know when the AI has detected that they've actually switched to going off topic. Then they can think about what are the mediating processes? Why would we do that? Well, maybe students can discuss the implications of why an AI would have determined the discussion fragment to be off topic. And this is, again, using the AI to teach AI, right? Because we're teaching them classifiers and so on. And then they may learn something about machine learning and intelligence and so on and so forth. So this is kind of just a mechanism in which people can get together. You have the the foundational AI people who are developing the algorithm, and this leads to maybe my algorithm is making a mistake in these edge cases. It's oversimplifying these other cases. Front-end decisions of the HCI people, the learning sciences who actually care about theory, can kind of come together and map these out. So we've kind of been doing this quite a bit. The other thing, and just to put it all together, is what does the whole process look like, right? So starting with these Learning Futures workshops as one kind of critical piece, then led to a design sprint that led to some metaphors, and then we're coming together to develop these different conjecture maps that kind of lay bare our assumptions and our hidden things. And then this helps us also think about how we can tune these algorithms that leads to some designs that can lead to some interfaces and also some physical interfaces. So this kind of process is a way in which people can engage at different levels and have artifacts that can promote a shared way of conversing. One other thing is that it also helps that we've always tried to be in person and in classrooms as much as possible. So here are just some of the activities we've been doing together. It was scary doing this all last year, but it's been really, really invaluable. And we have a long way to go. So this is just a complex diagram telling you the different sources of information that come up in our decision making. So there's a lot of inputs. I just spoke to you about some of them, but there's others. What can a computer actually do? What are the theoretical frameworks and so on? And then these design sessions serve as these convergence points. We have a lot of parallel work occurring in the lab. We have a lab set up where we can test some of these ideas. It's hard to do super experimental things in the classroom, and it's probably irresponsible to do those. So we can try to test some of these things with adults in a more, in a more safe manner, getting a lot of feedback, and then really coming together at these strategic points where we say, okay, let's take all the information we want, let's get everybody in a room, and let's figure a way that can work for almost, for everybody can buy in and have these shared values. So these things take time, and we're actually hoping to do another one of these in the next month. So with that, thank you for your attention. I just wanted to share with you about our institute and our goals of promoting deep conceptual learning through these rich social collaborative learning experiences for all students. And I encourage you to check out our website, www.isat.ai, to learn more. And thanks for your attention, and I'll be happy to take any questions.